טוב. Okay. Hi everyone. Welcome to my talk Under the Sea, where I'll show you how we can attack what I define as vulnerable sea creatures in snakes lands that actually be C code in your Python that I guarantee you don't know is there. So I'll grab my now clicker and I'll begin by introducing myself. My name is Aviad Hahami. I'm a security researcher at SNCC. This is my Twitter handle, and that's my email if you want to drop malicious PDFs. That's the time. Before we will begin, I'd like to basically convince you that the domain I'm about to show in the vulnerabilities world is very interesting and has a lot of impact. So we'll do some small game-ish. By raising your hand, I will read the names of libraries, frameworks, etc. If you are using or have used the libraries, please raise your hand and keep it up between questions. Very simple. So Python libs BML, has anyone ever used it? I'll be very surprised if yes. No, that's for metabolic systems, whatever. Proxy broker, that's more common one. Anyone? How about one of these frameworks for basically motion eyes OS? Okay, we have, can you keep it up actually? So motion eyes OS is for surveillance cameras and stuff like this. Home Assistant is for smart homes. Each one of those has 50,000 more stars on GitHub. And the last two giants is AIO HTTP and AIO DNS. Anyone? Good, more hands. You're all vulnerable. I can now say it because the CVE is out. We will touch it at the end, but I'm about to show you a cool domain that has a lot of impact and it is not known. Cool, so this is our agenda for today. We'll touch very quickly on combining languages. Why would anyone even put C in Python, right? This is a weird abomination. I'll tell you a bit about the research itself, what we've defined, what was the claim, what tools we had in order to research. Afterwards, we'll go for some hunting. I'll show you exactly what we've done in order to assess our claim and what were the results. And lastly will be this exploitation demo of one of these sea creatures. And you probably need to patch it if you're using AIO, HTTP or DNS tomorrow. So, okay, let's go. So why would anyone combine languages, right? We're using Python, it's already super cool, super high, memory managed. Why would we do that? And there are very simple reasons. You're all Python engineers, I believe you know. So during runtime, Python is slower than C, for example, right? This one is compiled, this one interpreted. There is a payoff that we have here, but usually we are okay with it. In some cases we are not. If we are writing, for example, a real-time system, we need what's called deterministic knowledge of our memory usage. In other words, we cannot rely on the garbage collector of Python, which is non-deterministic. We don't know when things will be cleaned. C gives us this granularity. More examples will be Bitcoin mining via the GPU, stuff like this. C has the great interface to this. It comes with overhead of, again, you need to manually manage everything, but some benefits. So with that being said, we know that some engineers do need to do so. Cool. With that assumption in mind, I believe most of you are running pip install every other day and you have your requirements txt or pip file or poetry, whatever. There is no PM for Python and C, right? I mean, so how do we do that? I will show you two methods that we've seen in the research, and I'll show you exactly what's the problem in each one, and using those we will base our research and continue. So copy paste, obviously we all know it's bad, right? I'll use the safe words, it's bad. And I'll example this using this cool library called Wisdom, some AI platform for reinforcement learning from visual information. Cool. Jumping to their GitHub, they have a zlib as a dependency. If you don't know, zlib is basically the algorithm for z inflating, deflating in your memory. Cool, everybody knows. But I want to show you something. If you look to your right, all these files that are the source code of zlib were basically pasted in the repo 6 years ago. Now, if we'll jump to zlib themselves, which I know you may ask, like, what's the difference in zip, right? It's the same stuff, but things change. The current release is from March 27th. So we have a gap of around 6 years between Wisdom's zip code and the actual zip code that is running in outside. So this is one problem. A second way that one will maybe want to require C code in their Python code will be via Git submodules. I don't know if you are using those or you are familiar with them. Git submodules are if you're not familiar, are very simple concept of basically pointing at a repository in a specific hash, right? In this example, repo A points at repo B at whatever hash. Cool. In the wild, it will look something like this. This is specifically PayPal's Bootstrap accessibility plugin, something I just found online. And they have this cool line, right? It's like href, so it's blue with link. And we can basically see that they require as a submodule BS3 is Bootstrap 3, BS3, sorry, at commit AB, whatever. Now, do note that this reference was committed 8 years ago. Cool, this can indicate about something weird. Now, jumping to Bootstrap themselves, the Bootstrap 3 where we're pointing at, per this snapshot, which was last week-ish, we can see that there was a commit yesterday, right? Now, let's put it chronologically. Bootstrap accessibility plugin points at this commit, let's call it AB6, and the actual head is at D05. Now, a good question will be what happened meanwhile, right? Our Bootstrap accessibility plugin is basically using a version which is 8 years old-ish. To give some numbers, there are roughly 11,000 and a half commits in between these two. So if we would like to think of it with a security prism, we can basically say that even though Bootstrap accessibility plugin shows features and progresses and the repository seems up to date, their security with respect to Bootstrap is as good as it was 8 years ago. Now this introduces a problem. And I'm going to show you exactly what this problem can do. And with that I will wrap the first bit of why would we even mix the languages and what's the reasoning. So we know by this point, we know that there are reasons to do so, cool, and we know that there are methods to do so, but there is no convention, and people basically do whatever they want, and there are problems with this. Now, there is danger in getting wrong versions, and let me show you exactly what was our research. So, what was our claim? We claimed that if we look into high-level languages packages, the research originally was not only for Python, but specifically now the showcase is for Python. You don't see the yellow, but it's highlighted. So if we look into high-level language packages that integrate C files, we'll be able to find C vulnerabilities or originated in C vulnerabilities. Cool, that's a nice claim, but the surface that we are dealing with is copy-paste surface, is stuff getting out of date, and specifically it's C. C doesn't have package manager, there is no pip. So how would we do that? And the next bit will be what tools do we have in order to research this. So this is not a commercial by any means, but Snyk acquired roughly a year and a half ago a company called FOSS-ID. Now, I'm not here to talk about what's coming out of it, but I am here to talk about what these guys do. They have a lot of cool stuff, but they do one thing super good, and this is snippet matching. So using FOSS-ID, I can now take any basically line of text, right? Code is text by the end of the day, and correlate it to its first occurrence ever on the internet. Now, this is specifically bzip2, whatever, and you can see the diffs and it points at stuff. Cool tool, right? I can point at anything. Now, if we combine it with our SNCS vulnerability database, I can not only correlate this line to a file, I can also correlate it to a CVE. Now, CVE, for those of you who are not familiar with, is basically the way you enumerate, or the community enumerates vulnerabilities, where the first digits are the year and the later ones are just an incremental number. Cool. So we have a claim. We believe that there are problems in C files within Python, and we have a tool to correlate C files to where they were originally at. So we went hunting, and our next step was cool. It had some problems scale-wise, but it was cool. We basically downloaded everything on PyPI, 100% of the packages and their versions. Every package was unwrapped, tarballs by the way, so we won't install anything. Was unwrapped into our GCP instance, and then it was processed by a few of our mechanisms, including the snippet matching one. And lastly, it was thrown to BigQuery for some later analysis. Very standard workflow, but with cool data set, I'd say. Let me give you some numbers. So at this time, there are almost, let's round it up, almost 400,000 packages, not unique packages, and I'm not talking about versions, in PyPI. Out of which 1.7% seem to be allegedly vulnerable. And I'm saying allegedly with care, sorry, because sometimes false positives happen, etc. And we can't just say everything that matched is true positive, vulnerable, blah, blah. It doesn't work like this. And I'll also add that while 1.7 may seem a small number in percentages, but in real life, it's almost 6.2 thousand libraries. And again, not versions included. So these are a lot of numbers. In the next bit, I'm going to show you exactly one of the findings and how it impacts everybody here. By raise of hand, who here works with Kubernetes or familiar with? Cool, we're all suffering, nice. I'm going to show you how to manipulate PyCares to SSRF. SSRF, server-side request forgery, it basically means I'll make your server connect or basically create a request to somewhere you didn't expect. Cool. PyCares, because I believe anybody here knows about this library? No? Right? Cool. Exactly. So PyCares is a very simple DNS resolver in Python, but in actuality, it's actually the resolver behind AIO DNS, AIO HTTP, Tornado by Facebook, and some more. This is its GitHub stars page, right? Nothing fancy. There is not much traction. Something not everybody knows, and usually no one, that it wraps C code behind it of a library called CVEs. I'll just refer it as CARES because I don't know how it's pronounced. And CARES is just a very simple implementation of DNS resolver, like dig that we have, we also have CARES. Cool. Something happened last year though, and CARES got a CVE. Someone found that there is a problem with DNS resolution in specific condition, and TLDRing this, it can't handle null bytes in CNAME response, okay? So, how does it actually look? Assuming we have a C areas client, I'm a bit short on time, so I'll speed it up. So if we have a client and we are asking public DNS servers, do you have some domain bananas? The public DNS server says like, I don't know, but this server knows, right? This is how DNS protocol works. They redirect you to someone else. This server is attacker controlled. And when I ask it for domain bananas, and it says, sure, this is the domain now. Now let's look at what happens in PyCares. The response is Kubernetes.default null byte, which is obviously wrong here, but this is still the response, .sum.bananas. Now, again, we are in CARES world. CARES is a C program. In C, null byte is string termination. So basically what CARES sees here is to the left Kubernetes.default, and it just drops everything to the right. This makes the next request go to Kubernetes.default, which I believe you all know it's very bad that one of your clients will hit that endpoint. Cool, cringe, but that was CARES. Now, let's go back to PyCares. As I said, it's just a wrapper around CARES. Now, if we'll jump into the repository, we can see again the submodule gimmick, right? It's whatever commit, which was 14 months ago, but actually I want to point that this is 809, because if we'll go into the CARES GitHub, sorry, repository, we can see to the bottom right the 805 commit, which PyCares points at, and we can see 3 commits up the chain or up the tree, the fix. This renders PyCares vulnerable. So, right before we'll jump into the demo, I want to show you a chain of impact. This is the blast radius from PyCares. The CVE came out last night. PyCares is over there at the top. Sorry, the CARES, then it's PyCares, and then everybody that suffers from it. We have Motionize 7,000 stars on GitHub, Tornado 20K stars, Home Assistant 53, AO HTTP 12.5, and this is just by a very quick surface scraping. Cool, I promised a demo. In our demo, we're gonna have 2 entities. It's gonna be a very quick demo. We're gonna have a very simple client that will do 1 request with PyDig resolver, this line, and PyDig is just another DNS resolver. And with PyCares, write 2 responses, and we'll return them as a result. The second thing that I have, the second entity basically is a stupid, silly DNS server that for whatever query just replies with Kubernetes default null byte, yada yada. This, actually I had it in DigitalOcean, was a cool POC, it works, yeah. So with that being said, let me jump into the demo. So to the left we have a Docker Compose with the example and the DNS server. I actually like the GTA music, leave it on. To the right we will perform requests to the client that I've shown you. This is just a silly thing I added for the sake of demo, but basically we're gonna do curl, provide the name server, which is the DNS server, and provide the host name, and as we can see, PyCares trimmed everything after the null byte, and PyDig did not. Cool, now back to reality. Let's assume this is our cluster, and we have a PyCares agent, right? In the PyDig, the next request was .google.com, the next request will go to Google. But in PyCares, it will go to your cluster Kubernetes master, basically, and this is how you would SSRF any company or any product that uses that. Some takeouts. So there is no de facto solution. I'm sorry. Except for me and more like me that are catching these things and reporting this, there is no de facto solution. There is no package manager that closes or seals all the cases. So if you are not using C, this is a general advice, use some package manager, pip, whatever. You probably have on GitHub plenty of providers that will do some dependency scanning for you. This is like the bare minimum, I believe. And if there is no such solution in hand and you are using C, create some mechanism of tracking the git head of the submodule, or per solution find your relevant remediation for this problem, because there is no solution again. Something to note is that always be aware of what magic is in your code, right? Everybody that uses Tornado, I guarantee that don't know they have C code in their repository, in like their project that is being compiled every time. This is 100% guarantee. So always be aware of what's coming in through your pip install, whatever, and stay up to date, right? Yeah, that's basically it. Any questions, stuff like this? Q&A?
How long did it take to download PyPI?
4 hours. 4 hours for latest. For the full scan was like a day or so. GCP, like, was a GCP beast.
How much space did it take?
Not much, because we were like in place. I was deleting anything I didn't need. So, sorry?
They didn't block you.
They didn't. My mistakes blocked me because I ummed the machine, and then like I filled the memory. I did some stupid mistakes, yeah. But I developed, right? Anything? Anyone? Yes. The question was, I mentioned false positives. How about false negatives? We had around some specific C Python stuff because C Python, again, I'm snippet matching, right? C Python is auto-generated. It's very hard not to miss point, I'd say, right? We did have to create some criteria and filters in order to overcome this, but yeah, we did have them in the raw dataset. If you're using OHTTP, go update because this is public now. Yeah, thank you.